Hi my dear students, welcome back again. In this lecture, we are going to discuss previous year questions from the concept of algebra of complex numbers and from the years 2022, 23 and 2024. We'll start with question number 1. Coming to the first question, if the set R is equals to a set of ordered pairs of A comma B such that A plus 5B is equals to 42 and both A comma B are natural numbers has m elements and given something else, then we'll see first total number of elements in this particular R. Look at this friends, A plus 5B is equals to 42 where A comma B both natural numbers. In that case, A will be equals to 42 minus 5B, correct? So in this case, B can take 1, yeah, if B is 1, A will be a natural number. B can take 2, yes. B can take 3, yes. B can take 4, yes. B can take 5, 6, 7, 8, 8 5s are 40. If B takes 9, 9 5s 45, 42 minus 45, A will be negative 3, which is not a natural number. So that means for each A, for each B, we'll get one distinct A. So we will be getting total 8 ordered pairs in this capital R. So the value of M is equals to 8 now. Then it is clear. Okay, half part of the question has been solved. Now coming to the next part, they have given sigma n equals to 1 to m. Here the value of m is 8 of 1 minus I raised to n factorial. This is equals to some x plus iy. Acha. Let's see this friends. Now we put n equals to 1. 1 minus I raised to 1 factorial is 1 plus 1 minus I power 2 factorial. Put n equals to 2. 2 factorial is anyhow 2 plus 1 minus I power 3 factorial. 3 factorial is 6 plus 1 minus I power 4 factorial and so on till 1 minus I power 8 factorial. In integral powers of iota, we have seen friends, I raised to power multiples of 4. I raised to power 4n, I power 4n is all 1. Clear? So that means from 4 factorial, each term, that means in 4 factorial, 5 factorial, 6 factorial, 7 factorial and 8 factorial, all these are multiples of 4. Okay? So all these values are 1 now. So 1 minus 1, 1 minus 1, 1 minus 1. That means from here all are 0. Okay, now let's focus on only these three. I square is minus 1. I square is minus 1. So 1 minus of minus 1, we have got plus 2. Next, this is already there. 1 minus I power 6. I power 6 can be written as I power 4 into I square. I power 4 is plus 1 and I square is minus 1. Again 1 plus 1 which is 2. 1 plus 1 which is 2 plus 1 minus I. So this is nothing but now 5 minus I. Now we are supposed to compare this with x plus iy. So x is equals to 5, y is equals to negative 1. Finally they are asking m plus x plus 5, 8 plus 5, 13, 13 minus 5, 12. The answer is 12. Clear ma? This was in 2024 question. Second question also from 2024. Let z be a complex number such that real part of z minus 2i divided by z plus 2i is 0. Real part of something is 0 means it is purely imaginary. Okay. So first we will equate the real part of that to 0. Let us take z is equals to some x plus iy. Z is equals to some x plus iy. So z minus 2i by z plus 2i can be written as x plus I times of y minus 2 divided by x plus I times of y plus 2. So this is what z minus 2i by z plus 2i. Now they have given the real part of this to be 0. First we have to express it in a plus ib form. For that we are supposed to multiply and divide with the conjugate of denominator. So when we multiply and divide with conjugate of denominator, x minus I times of y plus 2 divided by x minus of I times of y plus 2. So equate the real part to 0 friends. When do we get real part? We get real part if both real parts, corresponding real parts and corresponding imaginary parts are being multiplied. So in that case, x into x, x square, I into I square. I square is minus 1, minus 1 into minus, so that is into y plus 2 into y minus 2 is y square minus 4 is equals to 0. There will be denominator, but when you equate this to 0, even denominator goes to the other side and get cancelled. So that becomes x square plus y square is equals to 4. Clearly, x square plus y square is equals to 4 represents a circle with the center origin and radius 2 units. Clear? X square plus y square is equals to 4 represents a circle with the center origin and radius 4 units. That means our z lies on the circumference of the circle. It always moves on the circumference of the circle. Now what they are asking us to find? The maximum value of z minus of some z1. What do you mean by modulus of z minus z1? Modulus of z minus z1 means the distance between two complex numbers z and z1. To make it maximum, friends, see, this z is a point which lies on the circle. Okay, z is a point which lies on the circle. Let's say suppose this point 6, 8 is somewhere here. Now as z is a point which lies on the circle, what will be the maximum? When will this distance be maximum? If z lies on this other side. So in this case, this distance PQ will be the maximum distance. What is this distance? This distance is nothing but CQ plus R. So the maximum distance is CQ plus R. C is 0, 0. First we'll find the distance from C to Q. So clearly CQ is nothing but root over 6 square plus 8 square, which is 10, plus R is 2. So the maximum value is 10 plus 2, 12. Suppose if they ask minimum, then in that case CQ minus R. CQ minus R. So this will be the in that case RQ will be the minimum distance and PQ will be the maximum distance. Clear, friends? So hence the answer is 12. Next question. If z is a complex number, then the number of common roots of the equations, whenever z raised to high powers, the only thing in most of the cases which helps us is omega square, cube roots of unity, and even 1 also. Do check with either 1 or omega square. If these three satisfies, it's fine. If not, go with 2 minus 2 in that way, some other 2y minus 2y. Okay. So whenever we come across high powers, my dear friends, I repeat, high powers, cube roots of unity will help us, or even nth roots of unity also. Now coming to z power 1985 plus, there are two equations, z power 1985 plus z raised to 100 plus 1 is equals to 0. One equation, other equation is some z cube plus 2z square something. Now first check either z equals to 1, put z equals to 1, will it satisfy? No. Then put z is equals to omega. Z is equals to omega. What are omega? 1 omega square are cube roots of unity. So omega power 1985 omega power 100 plus 1 is equals to 0. Omega power 99, omega power 100 we can write it as omega power 100, we can write it as omega power 99 into omega. See friends, omega power multiples of 3 is always 1. So 1 into omega, this will be omegas. Clear? Now this we can write it as omega power 1982 into omega square, because 1982 is a multiple of 3. So hence this we can write it as omega square. Now clearly 1 plus omega square is 0, because sum of the cube roots of unity is 0. Hence omega is a root of this first equation. Let's try for z is equals to omega square also. If we go for omega square whole power 1985 plus omega power 200 plus 1 is a plus 1, we'll see. Now 1 is 1. This we can write it as omega power 198 into omega square. So omega square, and this is clearly omega. So all this is again 1 plus omega square is equals to 0. Therefore, for the first equation, omega and omega square are both the roots. Okay. Now let's see whether these two roots also satisfies the second equation or not. Clearly, friends, if we put z is equals to omega, omega cube is 1 plus 2 into omega square plus 2 omega plus 1. This is clearly 2 omega square plus 2 omega plus 2 common, 1 plus omega square. This is again 0. So that means z is equals to omega is a common root for both. Let's see for z is equals to omega square also. So omega square whole power 3 is omega power 6, which is 1, plus 2 into z square, that is omega square whole square omega power 4, which is omega, plus 2 omega square plus 1. This is again 0. So that means even z is equals to omega square is also the common root. So therefore these two equations have two common roots. Have two roots in common. Next question, friends. Let a not equals to b be two non-zero real numbers. Then the number of elements in the set x such that real part of az square. We'll do one thing. First we'll take something z is equals to some x plus iy. Real part of a into z square. What is z square, boss? Z square will be x plus iy whole square, that is x square minus y square plus I times of 2xy. Okay. Now let's see real part of a into z square. Real part of a into z square, which is nothing but a into x square minus y square plus bz, that is bx. Clearly this is the real part of this, correct? This is equals to a they have given, and second equation is real part of bz square, that is b into x square minus y square plus az, a into x is equals to b they have given. Acha, now what they are asking, let a not equals to b, we do two non-zero real elements, the number of elements in the set. How many number of elements in set x? Acha, that means number of elements in set x we need. That number of elements, number of x comma y values, number of z values, number of complex numbers which satisfies this equation. Okay. Friends, we'll add these two equations. Okay. Suppose if you add a plus b times x square minus y square plus a plus b times x is equals to a plus b. A plus b, a plus b, a plus b gets cancelled. X square minus y square plus x is equals to 1. Let this be one equation. Next, what will I do? We'll subtract these two equations. If we subtract, what happens? A minus b times x square minus y square plus b minus a times x is equals to a minus b. So if I cancel both sides a minus b, if I cancel both sides a minus b, here you get minus 1. Okay, so that means x square minus y square minus x is equals to plus 1. Let this be equation 1, let this be equation 2. Now we'll add these two, friends. We'll add these two. 1 plus 2. Let's see. X square minus, so that is 2x square minus 2y square plus x minus x gets cancelled. Plus x minus x gets cancelled is equals to now 2. Correct? Is equals to 2. 1 plus 1 is 2. So clearly x square minus y square is equals to 2 now. Okay? X square minus y square is equals to 2. Now we'll put x square minus y square is equals to 2 in this case. Okay? So what happens if x square minus y square is equals to 2, 2 plus x is equals to 1, which implies x is equals to minus 1. Which implies x is equals to minus 1. Okay, now we'll put x equals to minus 1 in any one among the equations, either this or that. We'll see. We'll put in this equation. What happens? 1 square is 1 minus y square plus x is minus 1 is equals to plus 1. So plus 1 minus 1 gets cancelled. From here y square is equals to negative 1. Friends, z is equals to x plus iy is a complex number only when x comma y both are real numbers. Now if y is a real number, can square of y can be negative? Never be. That means, so x exists, y does not exist. That means complex number itself completely does not exist. So number of number of elements in this set x means 0. Clear? Next question. Let a is equals to theta belongs to open 0 to 2 pi such that 1 plus 2i sin theta divided by 1 minus i sin theta is purely imaginary. If something is purely imaginary, then real part is 0. So 1 plus 2i sin theta divided by 1 minus i sin theta, let's multiply and divide with the conjugate, that is 1 plus i sin theta divided by 1 plus i sin theta. Focus only on numerator part. Now what will be real part? Real part 1 into 1 1, 2i sin theta into I sin theta is I into I square minus 1 minus 2 sin square theta is equals to 0. Real part we have equated to 0. Denominator no need to consider. So that means 2 sin square theta is equals to 1, sin theta is equals to plus or minus 1 by root 2. Friends, in 0 to 2 pi, now they are asking sum of the elements, no? See, plus or minus 1 by root 2 means we get 1 by root 2 in first quadrant and second quadrant, that is pi by 4 and pi minus pi by 4, and minus 1 by root 2 in third and fourth, pi plus pi by 4, 2 pi minus pi by 4. So if you add them, pi plus pi, 2 pi. Now sum of the elements we need, correct? Pi by 4, pi minus pi by 4 plus pi by 4, pi plus pi by 4, 2 pi minus pi by 4. 1, 2, 3, 4. So the answer is 4 pi. Sum of the elements in the set they are asking. Sum of the elements in the, actually A takes 4 values. One is pi by 4, pi minus pi by 4, pi plus pi by 4 and 2 pi minus pi by 4. They are asking us to find the sum of those. So we have added them. We got 4 pi as the answer. Clear? Next question. 1 plus sine 2 pi by 9 plus I cos 2 pi by 9. Friends, whenever we come across this 1 plus something, check whether can we use these formulae or not. Because 1 plus cos theta we have 2 cos square theta by 2 and 1 minus cos theta we have 2 sin square theta by 2. Here we have 1 plus sine, so we can convert sine to cos, correct? Because sin theta can be written as cos pi by 2 minus theta. So first, what is 2 pi by 9? Pi is 180. 180 by 9 is 20. 2 into 20 is 40. So sin 40 we can write it as cos 50, correct? So this we can write it as 1 plus cos 50 plus I times sin 50 whole divided by same 1 plus cos 50 minus I times sin 50. First we will simplify internal part, okay? 1 plus cos 50 is again from there 2 cos square 25 plus I times 2 sin 25 cos 25, because sin theta we can write it as 2 sin theta by 2 cos theta by 2. So 2 cos square divided by 2 cos square 25 minus I times 2 sin 25 into cos 25. Friends, we can cancel 2 cos 25 in numerator and denominator. Then what we get? We'll get something like cos 25 plus I sin 25 divided by cos 25 minus I sin 25. Friends, this we can write it as e power I 25, okay, divided by cos 25, this we can write it cos of minus 25 plus I of sin of minus 25. So e power minus 25, this we can write it as e power I times 50. Now the required one is e power I times 50 whole cubed. So e power I times 150 degrees. Okay, so 150 is nothing but this is nothing but cos 150 plus I times sin 150. Cos 150 is cos of 90 plus 60 minus sin 60 minus root 3 by 2 plus I times sin 150 is sin of 90 plus 60 cos 60, which is 1 by 2. So if we take minus 1 by 2 common, root 3 minus I will be the correct answer, which is option C. Clear, friends? Instead of what we do, instead of multiplying and dividing with the conjugate of the denominator, this makes sense. Try to do this, okay? Next question. For two non-zero complex numbers z1 and z2, if real part of z1 into z2 is equals to 0 and real part of z1 plus z2, we do one thing. First, let z1 is equals to some x1 plus iy1, z2 is equals to some x2 plus I times y2. First equation is z1 into real part of z1 into z2. What will be real part of z1 into z2? That is x1 x2 minus y1 y2 is equals to 0. Okay, x1 into x2 minus y1 into y2 is equals to 0. Next, real part of z1 plus z2. Real part of z1 plus z2, that is x1 plus x2 is equals to 0. x1 plus x2 is equals to 0. Okay. Now from this we can say this, friends. If x1 plus x2 is equals to 0, that means x1 and x2 are having opposite signs. Correct? Then only sum will be in 0, no? Suppose if x1 negative, x2 positive, x2 positive, x1 negative. Okay, that means x1 into x2 product will be negative now. Clear? Now negative is equals to, see, from here we can say y1 into y2 is equals to x1 into x2. But we got x1 into x2 is negative. So that means y1 into y2 is negative. y1 into y2 is also negative. That means both y1 and y2 are also having opposite signs. y1 and y2 will also be having opposite signs. So among the options, opposite signs means we can't say directly that y1 is having positive, y2 negative. So but it is very sure that both should have opposite sign. That's it. So in that case, first option is y1 y2 both positive. No. Second option is y1 negative, y2 positive. Fine. Third option is y1 positive, y2 negative. Fine. Both negative. So only B and C. That means option B is correct answer. Clear, ma? Exactly, yes. Next question. The real part of the complex number 1 minus cos theta. See, it's a mixture of trigonometry we use, trigonometry formulae we use, complex numbers we use, and even definite integration also. Clear? See, let's see first real part of that complex number. First, what is that complex number? 1 by 1 minus cos theta plus 2y sin theta. Is real part of this is 1 by 5. First we'll multiply and divide with the conjugate. Here you can use 1 minus cos theta as 2 sin square theta by 2. We can use it, but let's see, we can use that, or without even that also we can. 1 minus cos theta minus 2y sin theta, we are multiplying and dividing with the conjugate of denominator. 1 minus cos theta minus 2y sin theta. So clearly now real part is only, see, 1 minus cos theta will always be in anyhow numerator, and this is anyhow a square plus b square, that is 1 minus cos theta whole square plus 2 sin theta whole square, which is 4 sin square theta. This is equals to 1 by 5. Now cross multiplication, 5 minus 5 cos theta is equals to 1 plus cos square theta minus 2 cos theta plus 4 sin square theta. That 4 sin square we can write it as 1 is sin square Sine square theta plus remaining 3 sine square theta, we can write it as 3 times of 1 minus cos square theta, friends. Because we have cos, no? Let's try to express everything in terms of cos. Now sine square plus cos square is 1. 5 minus 5 times of cos theta is equals to 1. Cos square plus sine square is again 1. 1 plus 1, 2 plus 3 plus 2 plus 3 ones are 3 minus 3 cos square theta. We have minus 2 cos theta also. Okay. 1 plus cos square plus sine square is 1. 1 plus 1, 2 plus 3. So this 5 got cancelled clearly. That too. Okay, done. Now what we got? Minus 3 cos square theta, will take it to the other side. 3 cos square theta. 5 cos theta, you take it to the other side. We get 3 cos theta. So that becomes clearly 3 cancel. Cos square theta minus cos theta is equals to 0. So what we can do? Cos theta into cos theta minus 1 is equals to 0. Either theta is equals to 0 or theta is equals to pi by 2. Because if cos theta 0, cos theta equals to 0, then theta is equals to pi by 2. Cos theta 1, theta is equals to 0. So anyhow, theta equals to 0 is not in the solution. Why? Because theta belongs to open 0 to pi. Theta equals to 0. Open means not included. So theta equals to pi by 2 is our required answer. Now from this we are supposed to do integral 0 to pi by 2 sin x. Integral sin x is minus cos x. So minus cos x from 0 to pi by 2. That is minus of cos pi by 2 0 minus 1, which is plus 1, friends. Answer is option A, plus 1. Clear? See, mixture of trigonometry. We used trigonometry, complex numbers and even definite integration. 9th question. Let u is equals to 2z plus I divided by z minus ki and z is equals to x plus iy and k greater than 0. Oh my god. If the curve represented by real part of u plus imaginary part of u is equals to 1, intersects y-axis at so 2 points where PQ, then the value of k. Acha. First they have given z is equals to x plus iy, no? So first we'll simplify this u. U is 2x plus I times of 2y plus 1. Correct only, no? This is 2x plus 2iy plus I. So I common. Z minus ki, that is x plus I times of y minus k. Fine. This is now what we do in general to express it in a plus ib form. X minus of I y minus k divided by x minus of I times of y minus k. So friends, first what is real part? Directly I'll write. Real part is 2x into x, 2x square plus I into I square. I square is minus 1, so minus into plus, that is plus 2y plus 1 divided into y minus k. Okay, fine. Whole divided by x square plus y minus k whole square. Okay, this is real part. Now what is imaginary part? Imaginary part, you will get imaginary part if you multiply 2x into this, that is, first we will multiply x into 2y plus 1, x into 2y plus 1 minus 2x into y minus k divided by x square plus y minus k whole square. So friends, now they have what they said, imaginary part, real part of u plus imaginary part of u. So this sum is equals to 1 now. Okay, this sum is equals to 1. So that means this is equals to 1. Now the curve which is represented by this intersects the y-axis at the points P and Q. What do you mean by intersecting y-axis? Intersecting y-axis is nothing but put x equals to 0. So we'll put x equals to 0 now. We'll put x equals to 0 in this. If we put x is equals to 0, 2y plus 1 into y minus k is equals to y minus k whole square. Clear? Great. So let's try to take y minus k common. If y minus k we took common, then 2y plus 1 minus y plus k is equals to 0. That means either y equals to k or 2y minus y. Y is equals to minus of 1 plus k. Okay. Now what they are asking, let suppose, so this intersects y-axis means there are 2 points now. Point 1 is 0 comma k, 0 comma minus of 1 plus k. What is the distance between these 2 points? The difference of this. Clear? The difference of this, that is k plus 1 plus k. So 2k plus 1 is equals to 5, 2k is equals to 4, k equals to 2 is the answer. K equals to 2 is the answer, which is option D. Clear ma? If a and b are two real numbers such that 2 plus alpha power 4 is equals to a plus b alpha, where alpha is, what is this alpha? Minus 1 plus I root 3 by 2 is nothing but omega. Here alpha is equals to omega. Okay. Now first we'll do 2 plus alpha whole square. Okay. So that is 4 plus omega square plus 4 omega. Correct only, no? 4 plus omega square plus 4 omega. So if you take 4 common, we get 1 plus omega square. We already know 1 plus omega square is equals to 0. So 1 plus omega is minus omega square. Now minus 4 omega square plus omega square will be minus 3 omega square. That's it. Now this is that. Now 2 plus alpha whole power 4 is nothing but minus 3 omega square whole square it is. So 9 into omega power 4, and 9 into omega power 4 is just omega, because omega cube is 1. So this value is just 9 omega now. Okay. This value is just now 9 omega. So now they are asking us this is equals to a plus b omega. So that means a0 b equals to 9. And they are asking a plus b, friends, which is 0 plus 9, which is 9. See how simple it is in terms of cube. If we know cube roots of unity, then we can solve it easily. Imagine if you are not aware of cube roots of unity and simplifying this big part. Okay, don't do that, don't do that. The value of this is equals to, again cube root of unity will help us, friends. See, we have omega is equals to minus 1 plus I root 3 divided by 2. So we don't have 2 here, no? For that what we do? We multiply and divide with 2 power 30. Minus 1 plus I root 3 divided by 2 whole power 30 into 1 by 1 minus I whole power 30. So this is clearly omega. Omega power 30. Omega power multiples of 3, which is 1. So this value is only 2 power 30 into I would like to do this 1 minus I whole square whole power 15. Friends, 1 minus I whole square is nothing but 1 plus I square. 1 I square is minus 1. So 1 minus I 0 minus 2y power 15. Multiply and divide with I in brackets. Okay. So I by, so 2 power 30 into I power 15 divided by I square is minus 1, minus of minus 2 is plus 2, 2 power 15. So 2 power 30 by 2 power 15 is 2 power 15, and I power 15 is nothing but we can write this as I power 12 into I cube. I cube is minus I. So that which is minus I into 2 power 15, minus 2 power 15 into I. This is the answer. Clear? If we know omega and its properties only, there are many applications of cube roots of unity, dear friends. Next question. Let z belongs to C with imaginary part of z is equals to 10. That means z is equals to some x plus 10i. Okay. and it satisfies 2z minus 10 divided by 2z plus n is equals to, first what is 2z boss? 2z is nothing but 2x plus 20i it is not 10i, 2x plus 20i. So that means 2z is equals to 2z minus n, that is 2x minus n plus 20i is equals to 2i minus 1 into 2z. 2z is nothing but 2x minus n, 2x plus n plus 20i it is, plus 20i. Okay, now we'll equate real parts and see real part is 2x minus n, this is equals to real part in this is minus 2x minus n, minus 2x minus n, 2i into 20i which is minus 40. So clearly minus n gets cancelled, minus n gets cancelled, this is 2x, 2x plus 2x is 4x is equals to minus 40, x is equals to minus 10. So we have got x is equals to minus 10 now. Put that x is equals to minus 10, put that x is equals to, or we'll equate corresponding imaginary parts. Imaginary part in the left is 20, this is equals to 2y into, I mean I common like, so 2 2s are 4x plus 2n, okay, then 20i is, that is minus 20. So 20 plus 20, 40 is equals to, what is this, 4x, that is minus 40 is equals to minus 40 plus 2n, 2n is equals to 80, n is equals to 40. Therefore the corresponding values of x and n are minus 10, sorry, real part of z is minus 10, fine, n is equals to 40, which is option C. Clear ma? In the beginning I have taken z is equals to x plus 10i, but 2z as 2x plus 10i I have taken, okay, do not commit such mistakes. Next question, see again they have given a complex number as purely imaginary. If it is purely imaginary, we equate the real part of that to 0. So what will be real part? Just I am taking it directly, 3 plus 2y sin theta, we multiply this with what? We multiply this with 1 plus 2y sin theta, and we equate that real part to 0. So real part of this we equate it to 0. So what is the real part of this? 3 1s are 3, 2y into 2y, that is minus 4 sin square theta is equals to 0. Sin square theta is equals to 3 by 4, sin theta is equals to plus or minus root 3 by 2. But the solutions he is asking from minus pi by 2 to pi. See friends, minus pi by 2 is here, pi is here, that means from here to here he is asking, okay. Now sin theta will be positive in two quadrants, first and second, negative in this quadrant, fourth quadrant, okay. So we need three values now. Root 3 by 2 will be pi by 3, pi minus pi by 3, and minus pi by 3 in this, that's it. Oh my god, directly we got. So now what are all the values that we got? Sum of all the elements we need, pi minus pi by 3 plus pi by 3, pi by 3 minus pi by 3 gets cancelled, pi minus pi by 3 which is 2 pi by 3 is the answer. Sum of all the elements. Suppose if they ask number of elements, we got 3, sum of means we have to find the sum of all those. Clear? Next question friends, z is equals to root 3 by 2 plus I by 2. Friends, if we can express it in polar form, that will be very simple. Polar form is polar form or even Euler's form also. Root 3 by 2 plus I by 2 is, we can write it as cos 30 degree, yeah, cos pi, see this is cos pi by 6 plus I sin pi by 6. So this we can write it as cis pi by 6 whole power 5 plus cis minus pi by 6 whole power 5. We can directly write this as cis by using de Moivre's theorem, cis 5 pi by 6 plus cis minus 5 pi by 6. Nothing but what happens actually, cos 5 pi by 6 plus I sin 5 pi by 6 plus cos minus 5 pi by 6 plus I sin minus pi by 6. So you see friends, cos 5 pi by 6 plus I sin 5 pi by 6. Cis plus cos of minus 5 pi by 6 is cos 5 by 6 only, plus I sin minus 5 pi by 6 is minus I sin 5 pi by 6. So these two gets cancelled, that is nothing but 2 times of cos pi by 6, cos 5 pi by 6. So clearly real part is negative, imaginary part is 0, correct? But they have given only imaginary in terms of imaginary part, so hence answer is option B. Clear ma? We have used here de Moivre's theorem and polar form representation of the complex number, so that our problem became much easy. Okay, next, let minus 2 minus 1 by 3 minus I by 3 whole cube is equals to x plus iy divided by 27, where x and y are real number, then y minus x is equals to, let's see this friends, 3 2s are 6, that is minus 6 minus I divided by 3 whole cube is equals to x plus iy divided by 27. Anyhow this gets cancelled because 3 cube is 27. We'll cube this, first minus common, so minus into 6 plus I whole cube is equals to x plus iy minus 1 into 6 plus I whole cube is nothing but 6 cube 216 plus I cube minus I plus 3ab 3 6 I 18 18I into a plus b 6 plus I is equals to x plus iy. So friends, finally minus 1 into 216 minus I plus, we have 18 into 6, 18 into 6, 6 8s are 48, 6 1s are 6, which is 108, 108I plus 18I into I, 18I square, which is minus 18. Clear? So this is equals to x plus iy. Now clearly if you see this, 216 minus 18 is 198, correct? 198 into minus 1, that is minus 198. Minus I plus 108 is 107, but minus of what is this? Minus of minus 107I is equals to x plus iy. So clearly x is minus 198, y is minus 107. Now they are asking us to find what y. Y is minus 107 plus 198, which is 91 is the correct answer. Okay, see, simple, very simple, very simple. This is 2020th question. The least positive integer value of n for which this is equals to what? Friends, again if you know omega, cube roots of unity, see omega is minus 1 plus I root 3 divided by 2, whereas omega square is equals to minus 1 minus I root 3 divided by 2. Okay, now let's see this. This numerator we can write it as minus 2 omega square, correct? If I multiply with 2, see 2 omega square is equals to minus 1 minus I root 3, and minus 2 omega square is equals to 1 plus I root 3. Okay, divided by this is minus 2 omega, correct na? Because omega is minus 1 plus I root 3 by 2, 2 omega is minus 1 plus I root 3, minus 2 omega is 1 minus I root 3, whole raised to n. 2 gets cancelled. Minus my omega square by omega is omega power n. So omega power n will be 1 if n is equals to 3. Clear? The least positive integer it is going to be true is n equals to 3. Okay? Next question. Let omega be a complex number such that 2 omega plus 1 is equals to z. Z is equals to I root 3. See, z is equals to I root 3 and omega is equals to minus 1 plus I root 3 by 2, which we already know. What is omega. So in sum of the cube roots of unity, 1 plus omega square is 0, friends. Okay, so in this case minus omega square minus 1 we can write it as omega. So this determinant will be now 1 1 1 1 omega square 1 omega square. Omega power 7 we can write it as omega power 6 into omega, which is again omega. So just one operation friends, R1 changes to R1 plus R2 plus R3. 1 plus 1 plus 1, 3. This is 1 plus omega square, 0. 1 plus omega square, 0 again. 1 omega square, 1 omega square omega is equals to 3k. Okay. Anyhow, from first row we can take this 3 also common. So 3 out, 3 also got cancelled. Now let's see this. 1 into omega into omega square, omega into omega square minus omega power 4. Omega power 4 is, what is this omega power 4? Omega power 4 is omega only. This is equals to k, guys. Okay. So, but we already know 1 plus omega square is equals to 0, no? 1 into omega into omega into omega square minus omega square omega power 4. So omega square minus omega is equals to k. Then they are asking k in terms of what is this? Acha. Look at this friends. What is omega square? Omega square is minus 1 minus I root 3 divided by 2. Okay. Minus omega. What is omega? Omega is minus 1 plus I root 3 by 2. Now they are asking difference of this. So clearly minus 1 by 2 plus 1 by 2 gets cancelled. Minus I root 3 by 2 minus I root 3 by 2 minus 2 I root 3 by 2. So k is equals to minus I root 3. Minus of I root 3 is z. Therefore k is equals to minus z. Answer is option D. Clear? Next question. Actually, in this case, omega square minus omega. I expected the answer to be in terms of omega or 1 and all, but they said in terms of z and all. So we have to replace again omega square with its value. Omega square as minus 1 minus I root 3 by 2 and omega as minus 1 plus I root 3 by 2. Okay. A value of theta for which it is purely, see friends, how many questions we did based on the same concept. If it is purely imaginary, real part will be 0. What will be real part now? 2 plus 3i sin theta into 1 plus 2i sin theta. Real part in this, we equate to 0. 2 1s are 2 directly. 3i into 2i, that is minus 6 sin square theta is equals to 0. So sin square theta is equals to 2 by 6, which is 1 by 3. Sin theta is equals to plus or minus 1 by root 3. So theta can be either sin inverse of 1 by root 3 or theta can be either sin inverse of minus 1 by root 3. Theta can be either this or this. That means option D is the correct answer. How much time are we investing in this? Less than 20-30 seconds. So there are some questions from complex numbers which are really easy. 1 plus omega whole power 7 is equals to, what is this? A plus, see friends, in general actually, if we know cube roots of unity, what is 1 plus omega square? 0. So we can write 1 plus omega as minus omega square. Minus omega square whole power 7. We can write this again as minus, that is minus. Omega power 7 is omega power 14. Omega power 14, we can write it as omega power 12 into omega square, correct? Omega power 12, that is minus omega square. Okay? Correct only, no? Yes. 1 plus omega power, 1 plus omega is omega minus omega square, minus 1 power 7 is that. So 7 2s are 14, minus 14. Then we have got minus omega square. Now they are asking this in terms of 1 plus, see, minus omega square, we can write this as 1 plus omega, because we know 1 plus omega square is 0. So this, when we compare this, a plus b omega, a is 1, even b is 1, which is a comma b they are asking. Answer is option D. So majority of the questions from complex numbers can easily be solved by using the concept of cube roots of unity. Clear? Next, last question in this session, friends. If z square plus z plus 1 is equals to 0, where z is a complex number, then the value of z plus 1 by z whole square plus z square plus 1 by z square whole square. See, z square plus z plus 1 is equals to 0. What are the roots of x square plus x plus 1 is equals to 0? Omega and omega square. Omega and omega square. So if you put z is equals to omega, it should satisfy, it will satisfy. See, omega square plus omega plus 1, 0. That means z equals to omega is a root. So if you put omega in this case, see friends, omega plus 1 by omega whole square plus omega square plus 1 by omega square whole square. Guys, omega cube is 1. So this part is 1 plus 1, 2 square, which is 4, plus even this part is also 4. 4 plus 4. See, this part and this part is 4, because omega power multiples of 3 will always be plus 1. Plus what else left to 4, 5. 4, 5 also will be same like this. 4, 5 will also be same like this. Okay. Now 4 plus 4, 8. 8 plus 2 times of, see, omega into omega, omega square. Omega square plus 1, that is minus omega. Are you getting me? Omega into omega is omega square. 1 plus omega square is, we have 1 plus omega. 1 plus omega square is equals to 0. Okay. Now omega square plus 1. 1 omega plus 1 by omega, which is nothing but omega square plus 1 by omega. Omega square plus 1 is minus omega. So minus omega by omega, it is nothing but minus 1. Minus 1 whole square is plus 1 only. Plus. Getting ma? Plus. Omega square into omega square is omega power 4. Omega power 4 is again omega. 1 plus omega is omega square. Omega square by omega square minus omega square. Again 1. So this is clearly 8 plus 2 into 2, 4. 8 plus 4 is equals to plus 12 is the answer. Clear? So my dear friends, in this lecture, we have seen a very good questions based on the concepts of algebra of complex numbers. Based on the concepts of algebra of complex numbers. And from the years 2019, we have questions from 19, 20, 21, 22, 23 and even from 2024. Okay. So I hope you have understood this lecture clearly. Wish you all the very best for your preparation. Take care. All the best.